All right, so we did this example. Okay. Did we talk? What was the main thing? Like when we square root, what's the rule? You always get two answers. What are they? Positive, negative. Why? Good, because remember, square root means what times itself, and gives me a positive number, and a positive gives me a positive, and a negative gives me a positive. Yes, sir. Not mostly, all the time, right? Yes, and I did say that. I said, yeah, but when you're dealing with Pythagorean theorem, we always ignore the negative answer. And did I say why? Good, because we're talking about a side. We're talking about a distance, right? We're talking about a length of a side here, and you can't have a negative distance, right? Very good, very good. Sorry, we were past this. Did we? We only did one Pythagorean. We just finished that one. All right, good. So let's try this one. Let's try this one. So it's another Pythagorean theorem. It says, find the missing side of the following right triangle. And then I gave you a triangle. It's very important that I said right triangle. Why? Because if it wasn't right, I couldn't use Pythagorean theorem, right? If it wasn't a right triangle. So remember, they either have to tell you in the instructions like I did, or what's the other way? Have that little box. Without either one of those, can you use Pythagorean theorem? Not really. You really can't. However, if you did, and it works, then doesn't that kind of confirm that it was a right triangle in the first place? Right? So, there's that too. But, you would have to know all three sides. Does that make sense? Okay, so here, what's the difference between this example and the last one? I actually know my hypotenuse, and I know... So how do I know that this one is my hypotenuse? Okay, so I heard someone say it's the longest. Again, how do I know that's the longest if I don't know how long this? That's what I want. It's across the right angle. The hypotenuse is always across the right angle, correct? So then when I set it up, how's it going to be different here? 8 is really what? A or does it matter? A or B? No, so I can make it A or B. I'm going to say A, so it's going to be 8 squared plus B squared. Do I have to call it B, by the way? I could call it X, Y, happy face, it doesn't matter. B squared is equal to 16 squared, okay? So do you guys see that there's going to be a difference here, right, in the way we work this out? There's going to be a difference. It's not going to be simple, just, oh, add them together, because now my missing side is on the left, right? So do the math anyway. What do you get? Plus B squared is equal to 256. As a matter of fact, I'm sorry, guys. We're going to need calculators, so why don't you... All right, so we have 64 plus B squared is equal to 256. Now what am I going to do? Because remember, I'm trying to solve for B, which means I need to get B by itself, alone. Good. So then I'll do what? So I'll have B squared is equal to 192. And then now what? Square root it. So I'll square root both sides. So when you square root B squared, you're just left with B is equal to, what's the square root of 192? Okay, so let's see if y'all remember this from Algebra 2. Do you think I want decimals here? No, okay, sometimes they're okay. But do y'all remember what to do with radicals that are not perfect squares, meaning they don't come out to whole numbers? You basically break them down. You break them down, okay? You do what it's called, it's simplifying a radical, okay? So this is kind of why I put this one. What I'm looking for is this. You have to break this number, the radicand, the 192, into two numbers, okay? I'm gonna basically factor 192. So I'm gonna put in two numbers. However, one of those numbers I want to be a perfect square. Now when I say perfect square, do you know what I mean? Perfect squares are like so as I'm going down a list, like 1 times 1 is, try that again, 1. 2 times 2 is, 3 times 3 is, 4 times 4 is, 5 times 5 is, 6 times 6 is, 7 times 7, 49, 8 times 8, 9 times 9? 10 times 10? 100. And then, of course, does it stop here? No, I can go forever if I wanted to. However, these are probably the ones we're going to use. So, basically, guys, I'm asking you to do this. Does 192 break down into something else and one of these? Now, here's where most students make the mistake. If I give them a number, for instance, like square root of 10. Okay, we'll start simple. Square root of 10. Well, they're like, yeah, but can I break that down into 5 and 2? And I'm like, yes, you can. However, is either one of those a perfect square? No, so it doesn't help me, okay? So like if you can't break it down, like square root of 10, I can't break it down into a perfect square and something else. So I just leave it as the square root of 10. So what I'm asking you to do is 192, can it be broken down into one of these and something else? Daisy's saying yes. What, Daisy? So she's saying that 192 is, and you need to confirm because she could be wrong, so check. She's saying 192 is 64 times 3. Is that correct? Okay, now why does that help? Because 64 is a perfect square, I can actually take the square root of 64. And what is the square root of 64? 8. And once I take the square root of that number, it comes out. So it's going to look like this. 8 square root 3. Have y'all seen numbers that look like that before? Well, this is where they come from. It's because they were a larger number that was basically broken down into a perfect square and something else. So notice, the 64 was my perfect square, but because I took it out, it became 8 on the outside, and what stayed? The 3, the one that I didn't touch. Does that make sense? Yeah, the number that stays inside is the number that you didn't, that's the non-perfect square. Does that make sense? Do y'all remember doing it? Is that new, or y'all did it? You did it, right? It was just a long time ago, right? So, okay, so here's the thing. Here's what I kind of want to keep in your mind. Do I only look at these numbers? No, it could technically go bigger, right? It could be 121, it could be 144, but for the most part, it's going to be these perfect squares. All right? Any questions on that? Okay. Let's try another one. Actually, I'm going to give you time. You try this one on your own. You try this one on your own. I'm going to... Okay, so in this case, this one's actually simpler. What do I have? I have A and B, so I'm looking for. So your setup should be 7 squared plus 9 squared equals C squared. 49 plus 81 equals C squared. C squared is equal to what? 130? Wait. Oh, so 130 equals to C squared, right? And then now what? So basically C is equal to the square root of 130, correct? And then at this point, you noticed what? It's a decimal, so you didn't give me that. What did you try and do? Find factors. And? So, yeah, so the square root of 130 is a decimal, right? But remember, we don't want decimals, so we try and do what? Factor. So one of them being a perfect square. And? Did you find any factors? So 10 and 13 are 130, but what's the problem? Neither one of those is a perfect square. So, there is none. So, if there are no factors of your radicand, this is your answer. Okay? I do not want the decimal. So your answer is the square root of 130. Has everybody got that? Okay? So, there are no factors of 130, one of which would be a perfect square. Okay? But the thing is, the only way to know that is to try. That's the only way to know that. Okay? So you should have tried. Alright, any questions on this one? Good? Okay. Let's talk about distance formula. Okay? And it's exactly what the name is, guys. Why do you use the distance formula? to find the distance between 2 points. Why can't I just count? Because it's on a graph. So like for instance, if I were to actually plot these, okay? So 1, 2, if I were to actually plot these, so negative 2, 1 would be here, right? And 1, 2, 3, 1, 2, 3, 4 would be here. So why can't I just be like, oh, that's 1, 2, 3, 4. Could I? No, why not? It's a diagonal, right? Exactly. So this is a diagonal. So is it really 1? This is not the same as this. Does that make sense? Okay, as a matter of fact, the distance formula is a version of the Pythagorean theorem. And because if you think about it, couldn't I do this? Couldn't I say, oh, look, there's a right triangle there? And I could say, well, I know how long this is, and I know how long this is. Couldn't I just use Pythagorean theorem and find my c? Yeah, but instead of having to do all that, we just say, well, look, here's your formula. The formula is very simple. Square root of x2 minus x1 squared plus y2 minus y1 squared. Which, if you're paying very close attention, it's the Pythagorean theorem. A squared plus b squared, and then wouldn't I square root it to find c? Right? So this is a version of the Pythagorean theorem. It's just now on a grid. So these are usually really simple because all we have to do is just plug in. Where most people get messed up is, what do these mean? What is this? What are these two? They're which x? This is my second x, my first x, my second y, my first y. So what I like to do, guys, is I like to label. I like to label, okay? This is my first point, right? So that makes this one and y1, and that makes this one x2 and y2, okay? So now, simply plug it in. So I'll have the square root of what? 3 minus. So what happens, this is interesting. What happens when you minus a negative? It turns into a positive. So it's not minus a negative 2, it turns into plus 2 squared plus 4 minus 1 squared. Okay? And then I can just simplify. Just keep going. Just keep knocking it out. What is 3 plus 2? So 5 squared plus, what's 4 minus 1? 3 squared. I can even keep going. 5 squared is plus 9. 25 plus 9 is? 25 plus 9 is? 34. So I should get the square root of 34. I should get the square root of 34. And at this point, what should you try and do? Or what is the square root of 34? It's a decimal. So again, do I want it? So then what should you try and do? Find some perfect square factors. Are there any? The good thing is I don't have to go through my whole list, right? Because I can tell you right now that anything above 36 isn't going to work, right? So 34, is it divisible by 4? No. Is it divisible by 9? No. Is it divisible by 16? No. Is it divisible by 25? No, obviously that's too big anyway. So then guess what? That's my answer. Okay? So the distance between those two is square root of 34. Good? Not difficult, right? We good? Do me a favor, try this one on your own. Alright, so, help me plug this in. What would it look like? Square root of what? Negative 3. It's actually plus 5 because it's a minus a negative, right? So negative 3 plus 5 squared plus negative 2 minus 7 squared. And if I simplify this, this gives me, what's negative 3 plus 5? 2, so you should get 2 squared. plus, what's negative 2 minus 7? Negative 9 squared. Now, notice the difference on how I wrote, okay? It's just 2 squared, so I didn't have what? Parentheses. But on the negative 9, I have parentheses. Does it matter? Well, if you use your calculator, it does. Okay? If you use your calculator, it does. If you are going to square a negative number, it has to be in parentheses. Okay? So, 2 squared is what? 4. And negative 9 squared is what? 81. And of course, 4 plus 81 is 85. And can I break 85 down at all? The fact that it has a 5 means 25 would be my only option, right? And it's not, so then guess what? That's my answer. Are we good? Is everybody comfortable with distance formula? Did anybody, be honest, did anybody make that mistake and just put a negative 9 squared in your calculator? Okay, because here's what happens. Look, if I pull up my calculator, pull up my calculator, okay, and if I just do negative 9 squared, this is what it's going to give me. It's going to tell me negative 81, okay? But if I do this, it tells me positive 81. Which one is the correct way? The one with the parentheses. Why does it tell me negative? Because the calculator uses PEMDAS. And according to the calculator, exponents come before negative 1 multiplication. So it just simply squared 81, or 9, got 81, and then it's times negative 1, which is negative 81. Okay, so be very, very careful with that. All right, last thing we're going to talk about today is midpoint formula. Midpoint formula. Okay? Again, the point of midpoint formula is to find the point in the middle. And again, you can't just count and say, oh, that looks about right. You need to be more precise. The formula is very simple. Okay? It's x1 plus x2 divided by 2. And then it's y1 plus y2 divided by 2. And notice, it looks like a giant coordinate because that's the point. You're trying to get a point, right? You're trying to get a coordinate. So it looks just like this. All you have to do is them separately. We're going to do our x's together. We're going to do our y's together. Simply add them, divide them by 2, and there it goes, okay? So do me a favor, help me out. Plug me in for just the x's. Negative 5 plus 9 divided by 2. And let's just work on the x's real quick. So what is negative 5 plus 9? 4. 4 over 2 is? So you should get 2 for the x. And for the y's, plug it in. What is it going to be? Negative 3 plus 3 over 2. What is negative 3 plus 3? 0. What is 0 divided by 2? 0. So there's my midpoint. So this is my midpoint. So the midpoint is 2, 0, exactly between those two coordinates. Any questions on that? Pretty simple, right? You did, and again, this is not new, right? We good? All right, as we finish off, do me a favor, just try this one on your own. Just try this one on your own. All right, so help me out here. Plug it in. What is it going to be? So 5, now it's plus a negative 2. But when you're adding a negative, it's the same thing as just what? Just subtraction. So 5 minus 2 over 2. And the other one? Negative 4 plus 7 over 2. And now, guys, simplify. 5 minus 2 is? 3 over 2. Negative 4 plus 7 is? 3 over 2. Now, is this an acceptable answer? Yeah. You can leave it as a fraction, as an improper fraction. Or, if you wanted to, what is this? 1.5, 1.5. So it really doesn't matter. To be honest with you, in pre-calculus, I prefer fractions. Okay? We prefer fractions. Fractions are, I know you hate them, but fractions are just easier to work with when it comes to the harder stuff, okay? However, though, decimals are easier to graph, right? Because you can, pretty much everybody can tell me where 1.5 is, but it'd be hard to tell me where 7/8 is, you know what I mean, on a graph. So decimals, I understand, are useful when it comes to graphs or money or something like that. Okay, any questions on, this was all review, so any questions on Pythagorean Theorem, distance formula, midpoint, all good stuff, right? Not bad for a first day. All right, so